Welcome back, dear students. Today we'll start the new exercise, that is exercise 20b from chapter number 20. Okay, so before we start our next exercise, let's get introduced with few familiar figures. We'll see formula for calculating their area and perimeter. All right. So the first figure that you need to understand is rectangle. Okay, so if this is your length L and if this is your width W, then the area of this rectangle will be L into W. Okay, length into width, or you can say length into breadth. Okay, now next is perimeter. So perimeter formula is this one. Okay, and here this D stands for diagonal. Okay, so diagonal is calculated using this particular formula, square root of L square plus W square. Okay, so in place of this capital D, better write small d. Okay, right. So this is my formula for rectangle. Okay, now square. What is square? Square is also a rectangle. Okay, square is also a rectangle where both the length and breadth are equal. So in other words, I can say that each and every side of this square will be equal to each other. Okay, and by the way, one more thing. Each corner angle, okay, so each interior angle, we can say interior angle of both rectangle and square will be 90 degree. You can see this is 90 degree, this is also 90 degree, this is also 90 degree, and this entire thing is also 90 degree. Now if each side of the square is A, then area of the square will be A square, perimeter of the square will be 4A, and the diagonal, that is this, will be equals to root 2a. Remember, this a is outside square root sign. Okay, so you may pause the video and note down these two figure and their respective formula. Let's move to next one, next kind of figure. So next is parallelogram. Okay, so in parallelogram what happens is pair of opposite sides are parallel. For example, this one and this one, they are parallel. Okay, and similarly this one and this one, they are parallel. Alright, so for parallelogram, what will be area? Area is given by base into height. So if you call this as base, then this becomes your height. Okay, so the product of base and height gives you the area of the parallelogram. Okay, now what is rhombus? Okay, so let's understand what is rhombus. So rhombus is also a parallelogram. Like in case of square, you know that square was nothing but a rectangle where all the sides of the square were equal, right? So in this case also we will have the same. So basically rhombus is also a square, rhombus is also a parallelogram where all the sides are equal to each other. Okay, but one thing that you need to keep in mind is the diagonals. Okay, so there are two diagonals. So this one is one diagonal and this is another diagonal. So in case of rhombus, what happens is, in case of rhombus, diagonals will not be equal. Okay, so if d1 and d2 represents the length of the diagonal, then area of the rhombus is given by d1 into d2 whole divided by 2. Or in other words, what you can say is area of the rhombus is given by half into product of the diagonals. This is product of the diagonals. Okay, so this is one of the formula. So this is my, let's say, as I said, all the sides of the rhombus will be equal. So if I say that each side of the rhombus is A, then diagonal d1 is calculated using this formula and diagonal d2 is calculated using this formula. Okay, so here what happens is, if there is d2 here, then here you have to write d1. If there's d1 here, then you have to write d2 out here. So these are the three formulas that you need to know for rhombus. Okay, so you may pause the video and note down the diagrams and their respective formula. Let's see the last kind of figure that you need to learn in this particular chapter. So next is trapezium. Okay, so trapezium, what is trapezium? Trapezium is a closed figure, a quadrilateral, where only two sides are parallel. Okay, only two sides are parallel. Where here you see this side and this side, they are parallel. Okay, now if the length of the parallel sides are A and B respectively, that means from here to here is A and from here to here is B, and let's say if the distance between these two parallel side is H, basically H stands for height. So height is nothing but the distance between the parallel sides. So if the distance between the parallel sides is H, then the area of this particular trapezium is given by half into A plus B into H. So this is the formula for calculating area of a trapezium. Okay, you may pause the video and note down the respective diagram and the respective formula. So let's see the first question from the exercise. Question says, I'm taking question number 4. Calculate the area of the quadrilateral ABCD in which AB is equal to 32 centimeter, AD is 24 centimeter, angle is 90 degree, BC and CD they are equal to 52 centimeter. Okay, so the diagram looks somewhat like this. See here, diagram looks somewhat like this. First and foremost, angle A is given to be 90 degree. So you see, this is exactly 90 degree. Okay, now what are the things that are given to us? AB is given, so AB is given to be 32 centimeter. Okay, AD is given to be 24 centimeter, right? So AD is given to be 24 centimeter. Next is BC and CD, both of them are 52 centimeter. So BC, okay, so BC is 52 and CD, it is also 52. Okay, right. So let me make a smaller figure here. I hope you are able to see. So here I have drawn extra things. Okay, I have drawn extra things. So what are those extra things? You can see I have drawn BD, I have drawn the CP also. Okay, so here triangle ABD is a right angle triangle, isn't it? So if you observe this triangle, this is right angle triangle because this is 90 degree. Okay, so first what we'll do is we'll find what's its area. Okay, so its area will be half into, since it is a triangle and you have already seen the exercise on triangles, then you will be able to calculate what is its area. Okay, so it will be half into base into height. Okay, that is half into base is 32 and height is 24. So when you multiply, the area of triangle ABD will be 384. So area of only this part is 384 centimeter square. Okay, now what we will do is, again we will see BD. Okay, we'll find BD. So we'll find BD using Pythagoras theorem. Okay, so how do we find BD? We find BD using Pythagoras theorem, okay, which says hypotenuse square is equals to perpendicular square plus base square. Okay, so from there BD square, as I told you, BD square will be 24 square plus 32 square. We'll find BD. BD will be square root. Okay, so when you find the square root, you get your answer to be exactly 40. Okay, so that means BD is 40 centimeter for you. All right, now if we have got BD, now we have got BC also, we have got, we have got CD also, we have got BD, BC also. Okay, so we'll find now what is the area of this particular triangle. Okay, now all of you know BCD is an isosceles triangle because this is also 52 and this is also 52, right? So DP, okay, so let's find what is DP. So can I say that DP, okay, because when you draw a perpendicular, by the way, this is perpendicular, okay, this is 90 degree. So when you draw a perpendicular, what happens is this becomes 90 degree. Okay, so this becomes 90 degree and this one, they will also be bisected. So in other words, what I can say is this DP is going to be exactly half of BD. Okay, so that's what is written out here. Okay, now all of you know BD, just now you got BD to be 40 centimeter, isn't it? So you do the cancellation out here, you get DP equals to 20. Okay, now from right triangle DPC, okay, so from right triangle DPC, because you know that this is 90 degree, so this becomes your hypotenuse. Okay, so you have got the base, but you don't know what is perpendicular. So we'll find what is CP. Okay, so CP using Pythagoras theorem will turn out to be exactly 48. So you got your CP value. Okay, so therefore area of triangle DPC, DPC will be half into base into height. Base is 20, right? Base is 20 and height is 48. Okay, just wait a minute. DP is, this is 20. Okay, this has to be 20. Kindly make correction of this. DPC, just wait a minute. Yes, so this has to be 20. All right, so this has to be 20, make it 20, and when you multiply, it won't be 960, but it will be 480. Okay, so it's gonna be 480. So similarly, you find area of this triangle. See, because see, this one and this triangle both are same. Okay, so that's why their area is also going to be same. All right, so that's why, see here carefully. So that's why, all right, just wait a minute. What you can do here is, instead of writing this, instead of writing triangle DPC, what you can do is you can write DBC. Okay, DBC. Now if you write DBC, then this becomes your base and this becomes your height. Now base is 40, right, and height is 48. Okay, so don't write DPC, write it DBC. Okay, so that's why again here also you have to write DBC, not DPC. So that's why area of the quadrilateral will be area of this triangle, which is 384, and area of this triangle turns out to be how much? It turns out to be 960. Okay, so add them up, your answer will turn out to be 1344 centimeter square. So this will be the area of this particular quadrilateral. Okay, so you may pause the video and note down your solution. Let's move to the next question. So the next question says, the perimeter of a rectangular field is 3 by 5 kilometer. If the length of the field is twice its width, if the length of the it's twice its width, find the area of the rectangle in square meters. Okay, so let's see what is being asked here. So you have to find area in square meter and your perimeter is given in kilometer. Okay, so here what is said is length is twice its width. Okay, so if I take x to be the width, then your length is going to be double of the width, which is 2x, kilometer. Okay, so I am taking kilometer. So perimeter, all of you know perimeter is 2 into L plus B. This is the formula, L plus W, or you can write L plus B. Okay, now 2 is written in its place, L is, okay, so B is x and L is 2x. Okay, so you put the value of L and B. So this is given to it 3 by 5. Okay, so from here if you calculate x turns out to be 1 by 10. Okay, so that's why its width is given by x, which is 1 by 10. So width is 1 by 10 kilometer and its length is going to be 2x. That is, okay, all right, so if you convert this 1 by 10 kilometer into meter, it becomes 100 meter. Okay, and its length is going to be double of the width. So if width is 100 meter, then length is going to be double, that is 200 meter. Okay, now you are asked to find the area of the rectangle, right? So all of you know area is given by length into width. So we have length is 100 and width is, width is 100 and length is 200. So multiply them, you get your answer to be 20,000 square meter. All right, so you may pause the video and note down your solution. Let's move to next question. So next question says, the length and breadth of a rectangle are 6 centimeter and 4 centimeter respectively. Find the height of the triangle whose base is 6 centimeter and area is 3 times that of the rectangle. So basically here length and breadth are given. Okay, so length and breadth are given means you can find what is the area. So area will be L into B, that is 6 into 4, which is 24 square centimeter. Okay, now question is asking you find the height of the triangle whose base is 6 centimeter and area is 3 times of the rectangle. So basically if h is the height, then area of the triangle is given to be 3 times area of the rectangle, which is 24, isn't it? Now all of you know area formula is half into base into height, and base is given to 6 and height is h. Okay, so from here we'll calculate h. okay, do the cross multiplication, you get the value of h to be 24. So that means your height is 24 centimeter. All right, so pause the video and note down your solution. Let's move to next question. So next question says, how many tiles each of area 400 centimeter will be needed to pave a footpath which is 2 meter wide and surrounds a grass plot 25 meter long and 13 meter wide. So what is the meaning of this? Let's understand using this particular diagram. So you see, there's a grass field, okay, and within this around this grass field there is a footpath whose width is given to be 2 meter, okay. And what is the dimension of the grass field? It is given that dimension is 25 meter, that is length is 25 meter and your width is 13 meter, okay. So this is 13 meter and this is 25 meter, that's what is given to us, okay. And width of the path is given to be 2 meter, okay. Now question is asking you to find how many tiles are required to cover this particular footpath, okay, right. So what am I going to do is I'll just draw a small version of this diagram, okay. So I have drawn a smaller version of the diagram. Now what am I going to do is I'll find the area of the footpath, okay. So for finding area of the footpath, what am I going to do is I'll find area of shaded region in blue, okay. So area of the blue region plus area of the red region. Now see here carefully, if you see here carefully, this blue part is also a rectangle and this red part is also a rectangle, okay. Now if you want to find area of this blue rectangle, we need length and breadth. Length is 2 meter and breadth is, length is 25 meter and this breadth is given to be 2 meter because this is the width of the path, isn't it? So that's why it's gonna be, see, by the way, we have got a two blue paths, so that's why I have to multiply by 2, okay, double. So 2 times L into B, okay. So we have length is 25 and breadth is 2, okay. Plus similarly the red ones, so from here to here is 13 and from here to here is 2 and from here to here is 2. So this is 2 plus 13, 15, 15 plus 2 is 17, okay. So this length is 17 and breadth is 2 meter, so that's why length into breadth, that is 17 into 2. And since we have got 2 red regions, so that's why 2 is written in front. Now we quickly calculate this will turn out to be 168 square centimeter. So square meter, I'm sorry, this is 168 square meter. Now see, remember it is given in centimeter square, so better convert this also in centimeter square. So when you convert this into centimeter square, what you have to do is you have to multiply by 10,000, okay. So when you multiply with 10,000 you get this much, right. So this is your square centimeter, area in square centimeter. So number of tiles is found using the formula. You can write the formula instead of this: area of the footpath divided by area of each tile. Area of the footpath is given to be this much, we obtained to be this much, and area of the tiles is given to be 400. So when you do the cancellation, you get your answer to be 4200, okay. So today we will see only this much. You may pause the video and note down your solution. Thank you very much.